How many of you figured out where you made mistakes on, or where you struggled? Like maybe not made, you don't know why you struggled, but maybe where you're going to struggle. That's kind of what you want to ask questions on today. So on number 3, just remember that if it goes in evenly, which it does because there's not a remainder, this is a factor of that. That means 4x plus 1 times x squared plus 3x plus 6 equals this. Okay, so if we, just so that we're very clear on what we're trying to do here, let's see if I can get that on. So we know now that 4x plus 1 times x squared plus 3x plus 6 equals 4x cubed plus 13x squared plus 27x plus 6. Okay? That all equals that. Which means now when I started with a cubic, most of you don't know how to factor a cube. And you could try to take out a greatest common factor, but you can't, and then you're like, well, I don't know what to do now. I guess I could get my calculator out and try to maybe graph it and find zeros. Okay? What you do is you try to find a factor that goes into it. In this case, this goes into it. This linear factor times this quadratic. And then once you have a quadratic, once you're down to a quadratic, you have a bunch of options. Tell your neighbor 4 options you have once you have a quadratic to find the zeros. Okay, what's one? Yeah. Factoring, what's another? Yeah. Completing square, another? Yeah. Square roots, another? Yes. Graph it. Find the zeros that way, another? It's a big formula. Yeah. Quadratic formula. You can use all of those, or you could attempt all of those. You can't always use them all. But you can attempt to use those to factor once you have a quadratic. So if we can get it down to a quadratic, that's great. Okay? The key question that I would have is, like, how do you get that thing? How do you know what goes into it? And that's kind of what we start doing in our next lesson. Okay? All right, number 4. That's what we got. So we get a remainder there, which means x squared minus x does not go into it evenly. All right, make sure you put your place value holder in there. Any questions on those two? Yep.
Second to last step, we have 3x cubed plus 4x squared plus 3x.
Mm-hmm.
How'd you get the 4x squared?
Right. 5x squared minus x squared.
Oh.
Yep. Rory. Got something other than the 10x? So if you got something different, making sure that, so you had the 7, and 7 times x squared is 7x squared, 7 times no? You got 8?
I got 8 too.
Well, hey, maybe I'm wrong. All right, so, hey, so if I did make a mistake here, where's my mistake?
It's
Matt.
0x squared.
I have 3x cubed plus 4x squared.
You could have 1x squared, but it's 0x squared.
3 times 3x. So I have 3x times, oh yeah, 0x squared. All right, so that should be 5. Which makes that 8. Which makes this 8 right here. All right, which makes then that 8x squared there, and this 8x, which makes this 11x. Well done. All right. Good. Okay. Nope, I didn't make that one on purpose. I would have had it in pencil if I would have done that. No, well this is, but that's a photocopy. My original probably is in pencil somewhere. Okay. Any other questions? Good job. It's called rain, Thad. We live in the Northwest. Okay, number 5. X minus 8 minus 14 over x minus 2. We did that one, I think, as a class, yes? Number 6. X squared plus 2x plus 2. No remainder on that one. Yeah. Yeah, if you put the 1 in front of the x squared, that's fine. Yeah. Okay. Remember, your power is always, your power of your quotient here is always 1 less than your beginning power, because you're dividing by a linear. Okay. Number 7. 2x squared minus x plus 18 minus 108 over x plus 3.
Is that a 6x?
This is supposed to be 6x, yes. Good call. All right, and number 8. 2x cubed minus 3x squared minus x plus 4 over x minus 4. Okay. Any questions on the bottom part? Yes, Sammy? Because, how do you know 4 is the remainder when using synthetic division? You get to this last line. Because your first coefficient, that 2, has to go with 1 degree less than here. So this would have to be 2x cubed, and you just run out of things then. So 2x cubed, 3x squared, minus x, there's your constant, plus 0. And then there's nothing left. So that last thing becomes your remainder.
So to get the next thing you take away, you multiply the thing under the line by the constant.
Yeah, 4 times 2 is 8. Yeah. Kendall? Stretching. Okay. All right, next page. All right, number 9 is letter A. Number 10 is letter D. Number 11 is letter B. And number 12 is letter C. Okay, notice you could have used synthetic division on all those. Okay, how do you know you could use synthetic? What tells you can use synthetic? It's linear with x to the, or x with a coefficient of 1. Okay? Has to have that coefficient of 1. Unless you're going to do a different way. And there's a way to do it without that coefficient of 1. It just is more complex. You might as well do polynomial. Okay? All right. Very good. What I'd like you to do is take a look at the bottom problem. So 13 through 16, I will do my best to not spend a long time talking about these. But I do want to point out a few things on them. So, first thing I want you to do is I want you to actually follow the instructions on number 13, which says use synthetic division to evaluate the function for the indicated value of x. Okay, so evaluate that function for the indicated value of x using synthetic division. Okay. Okay, well, using synthetic division to do this, what goes in here? 2. You're just saying, hey, x has a solution of 2. So you put the 2 in there. You get negative 3, 4, negative 17, and negative 6. And then you go through the whole process, right? Just a quick review of it. Negative 3, 2 times negative 3 is negative 6. Add, negative 2, negative 4. And then we get negative 17, negative 4, negative 21. And 2 times negative 21 is negative 42. And we end up with negative 48. Okay? Now, what did that do? Well, it gave us we used synthetic division to evaluate the function for the indicated value of x. In other words, we put in 2 to this function to get the output of negative 48. That is our remainder in this, right? If we were to write this out, this would give you negative 3x squared plus 4x minus 17 with a remainder of negative 48 over x minus 2. It's whatever makes that 0. So it'd be x minus 2. Now, that's not what they're asking you to do. They're not asking for this answer right here. They're asking for the value of the function when x is 2. So the value of the function when x is 2 really is just your remainder. Okay, that is what the remainder theorem says. Like, look, if you were to actually put 2 into this and substitute those values in, so if I set this up and said, well, negative 3 times 2 squared, or 2 cubed, excuse me, minus 4 plus 4 times 2 squared, minus 17 times 2, minus 6, that's f of 2. Yeah, we do the math. That gives me 8 times negative 3, or negative 24. 4 times 4, which is 16. Negative 34 minus 6. All of that equals negative 48. So the question is, well, why didn't we just do that? Like, why did we do that? Okay? To rate the answer I have is to relate the two. All right? You guys, the remainder theorem, which is what one of the theorems that's in your book for this section, the remainder theorem, this is the remainder theorem. If a polynomial, f of x, is divided by x minus k, then the remainder is r equals f of k. Okay? What does that mean? It means this. Okay? That's what it means. It says your remainder is what you get out when you put that value in. Okay? Yes?
How come your equation doesn't have, or should it include the negative 2 and negative 21?
The negative 2. Oh, down here? Yeah, where'd I get the 4 from? I don't know what I was doing. I think I was looking at the top row. Sorry. But we're not worried too much about that, but you're right. Yeah. Yes? Yeah, so you guys, here's the deal. Now, if you're given this, hey, for those of you that are ready for me to be done, I definitely want to be done too. Okay, so when you're given this, you're asked to evaluate for the indicated value of x. If you want to use polynomial, go for it. Just remember your output is the remainder. If you just want to plug it in this way and find the output, you could do that as well. It's up to you. Please remember the input was 2, the output is negative 48. Yes?
So when you're like on the quiz and you're answering it, you just write it as -48?
No. Yeah, you just write it as negative 48. I guess if you wanted to, just making sure that you understand, like, hey, when it's 2, that's negative 48. Remember, this represents a point on a graph somewhere. That's a solution. Okay? But for what they're asking, the answer you'd want to give is negative 48. Yes. Any other questions? Okay, very good. Your assignment, I got it here for you. It's going to be 4.3, practice A. Woohoo! We move on to the amazing 4.4, and we have a quiz next week, an opportunity. Yeah.